Friends, you must have heard about demons in mythological stories whose hunger was so immense that they could devour entire villages. There are celestial bodies in the universe with an insatiable hunger just like those demons. Their gravitational force is so powerful that they swallow any celestial bodies that come near them, even light. These are known as black holes. In today's episode, we will delve into the fascinating details of black holes. Let's get started. The monster known as a black hole is a body with incredibly high density. It has so much mass in a very small area that its gravity becomes more powerful than any other force, even preventing light from escaping. This is why black holes are invisible. The existence of black holes was proposed in the 18th century based on the gravitational laws known at the time. According to these laws, the greater the mass of an object or the smaller its size, the stronger the gravitational force at its surface. These are the basic principles. Now, let's understand how a black hole is formed. Black holes are formed when a massive star ages, and its fuel, primarily hydrogen, is exhausted. Stars are immense, and their gravitational force is equally immense. This force pulls the star's material toward its center. However, hydrogen at the star's core generates intense heat, causing the star to expand. The pressure from this expansion counteracts the star's gravitational force, preventing it from collapsing inward. But when the hydrogen is depleted, there is no pressure to counteract the gravitational force, and the star begins to collapse. If the star is roughly the size of our Sun, it shrinks to about 100 kilometers in diameter, becoming a white dwarf or neutron star. It then slowly loses heat and energy over billions of years. However, if the star is 3 to 5 times larger than our Sun, its gravitational force is so strong that the collapse continues until the star compresses to a point smaller than a speck of dust and disappears entirely, becoming a black hole. The gravitational force of this highly compressed star is several million times greater than that of the original star. Now that you understand how black holes are formed, you might wonder how scientists know about their existence if they are invisible and do not let light escape. Just as we can't see the wind but can infer its presence by observing dancing flowers, scientists infer the presence of black holes by observing the irregular motions of nearby celestial bodies. Telescopes like Hubble have captured images showing gaseous material being pulled toward invisible points, likely due to the gravitational force of black holes. Scientists believe there is a black hole at the center of our galaxy that grows by continuously swallowing nearby stars. The great physicist Albert Einstein advanced our understanding of gravity through his theory of general relativity. He demonstrated that light travels at a finite speed of about 300,000 kilometers per second, linking space and time. In 1915, he showed that massive objects like black holes distort the four-dimensional fabric of space-time around them, creating the effect we perceive as gravity. To illustrate this, imagine a heavy iron ball placed on a sheet. The sheet deforms, and marble scattered near it will revolve around the ball before being pulled in. Here, the sheet represents space, and the deformation represents the gravitational force. This example also shows that time slows down in the outer orbit of a black hole. The next question might be, what happens inside a black hole? The simple answer is we don't know, as its gravitational force is so strong that even light cannot escape, making it invisible. We only know what happens outside it up to the event horizon, the point of no return. To escape the event horizon, an object must travel faster than the speed of light, which is impossible. To understand escape velocity, consider this example. To launch a satellite into space from Earth, it must travel faster than 11 kilometers per second to overcome Earth's gravity. To launch a satellite from the Sun, which has a much stronger gravitational force, it must travel at 618 kilometers per second. Now imagine a black hole, whose gravity is far stronger than the Sun's. To escape it, an object would need to travel faster than the speed of light, which is 300,000 kilometers per second. This means nothing can escape a black hole, not even light. Black holes are so hungry that they pull in every celestial body that comes near them, erasing all traces of the object. After swallowing a celestial body, a black hole's power increases as the mass of the absorbed body adds to its own, strengthening its gravitational force. Astronomers believe black holes may provide insights into the creation and destruction of the universe. There are two main concepts regarding the creation of the universe. One suggests that all the material in the universe once existed as a massive body that exploded about 14 billion years ago, spreading material throughout space. This expansion process continues today. The second concept proposes that the universe's creation and destruction occur like a pendulum. The original body of the universe explodes, spreading material, which then returns and is absorbed back into the original body, causing another explosion. This cycle repeats continuously. Black holes may play a crucial role in this process, potentially forming the original body of the universe by swallowing celestial bodies, leading to a new creation after an explosion. However, this remains speculative. That's it for today's episode. Friends, let us know in the comments how you liked this episode. See you in another interesting episode. Until then, goodbye and take care.